In this video 6.3, we are going to be solving systems using elimination. By the end of the video and work time in class, you should be able to say, I can solve systems using elimination. So far we've been solving with graphing. We've been solving using substitution. So this is a third method to solve a system. And the key is going to be to deciding which way to solve a system, which way is going to be the quickest. In solving using elimination, if you can see here, I have a system. I've got two linear equations, and I have the x terms lined up, the y terms lined up, and the constants lined up right on top of each other. And we can see that if we make this one problem, if we were going to add all of the terms, what happens when we add opposites is we get 0. So this is what the elimination means, is when we are seeing that when we simplify and get 0, something's been eliminated. So if I add 3x and 5x, I get 8x. Well, this is eliminated. That's 0. And then negative 22 plus 38 gives me 16. So then we can see through that elimination process, we just have x left over in our equation. So we can solve for x. And then if we know x, we can plug 2, which we know x is now, we can plug 2 into one of the equations from up above here. It doesn't matter which one you choose. Let's just pick the top one here. So we're going to put x, which is 2, replace the x with 2, and then we're going to solve for y. And then we have our y over there, so when we write our answer, we write it as an ordered pair 2, which is our x, negative 7, which is the y. So if we were to graph, that's where they would intersect. If we would have set one of the equations where we would get like the y all alone and use substitution, we would get the same thing. But we can see in this problem in particular where you have all the terms lined up and you can see elimination is going to happen right away. That's the method you're going to want to do. A concession stand sold a total of 138 small and large popcorns. A small popcorn is $2.50 and a large popcorn is $4. The total popcorn sales were $466.50. How many large popcorns were sold? We can set up two linear equations here. First, we know that a small plus the large was a total of 138. This is the first thing we know. We also know the cost, 2.5 for a small plus 4 for a large gave us the total of $466.50. Now you can see what I did here is I lined up the s's, the l's, and the constants the way I wrote my system. Now with elimination we need opposites so that when we add opposites we get 0. Or we can subtract too, like a value minus that same value and get 0. Well, in this case, we can see that we don't have opposites that we're adding, or we're not subtracting the same value from a value. So what we're going to do is we are going to make opposites. I'm going to take the top equation, and I'm actually going to use a different color here. I'm going to take my top equation, and notice I'm putting parentheses around the whole thing, and I'm going to multiply everything in the top by negative 4. The reason why I'm doing this, we distribute to everything. The reason why I'm doing this is because when I distribute that negative 4 through, I get negative 4s minus 4l. That would equal negative 4 times 138, which gives me negative 552. And so then the bottom equation, I didn't do anything to, so that one stays the same. It was 2.5s plus 4l equals $466 and it was 50 cents and a half. So what we see happens now is I created opposites. right here by multiplying that negative 4 to every term in the top equation. So I'm going to add these two equations. Negative 4s plus 2.5 gives us negative 1.5 s. Negative 4l plus 4l is 0, so that's eliminated. Negative 552 plus 466.5 gives us negative 85.5. We divide both sides by negative 1.5. And then s equals a positive 81. Oh, no, I'm sorry, that'd be a positive 57. And once we know that the s is 57, then we can find our L, which is 81. And we do that by taking s, plugging it into that original equation. That first original equation, because that's just the easier of the two equations we wrote. And so we said that s is 57, so 57 plus L equals 138. And the question was, how many large popcorns? And so not the small, but the large. And when you subtract 57, that's where you get your 81. So 81 large popcorns. Here's another system where when we look, we have the x's lined up, the y's lined up, and then the constants lined up here. Well, pretty much. And we see that we don't have opposites, so nothing's going to eliminate right away. So on this one, what I would do is multiply everything on the bottom by 3. That's one option. And by doing that, if I multiply everything on this bottom function by that 3, I'm then going to get a negative 12y, which is the opposite of 12y. So I'm going to rewrite the system. I have negative 2x plus 12y equals negative 30. And then I'm going to distribute that 3 to every term in this linear equation here. And then I'm left with 9x minus 12y equals 51. And so then when we solve here, when we're combining, if I'm adding, you can subtract, but subtracting here wouldn't eliminate. It would be adding would eliminate. 12y plus negative 12y gives you the 0. So negative 2x plus 9x gives me 7x. And negative 30 plus 51 gives me 21. And then if I divide both sides by 7, we're left with x is 3. So we know our x. And then we can take one of the equations from that we started with. It doesn't matter which one. Let's just pick the bottom one. 3x, which we're saying the x is 3. So 3 times 3 minus 4y equals 17. So 9 minus 4y equals 17. So negative 4y is 8, and divide both sides by negative 4, and then your y would be negative 2. So our answer, written as our ordered pair, is 3, negative 2. Same thing here. We see that the x's, y's, and constants are lined up, but we don't see anything that would eliminate right away. What I would do on this one is I'm not only just changing one equation, I'm going to change both, because I'm going to multiply the top equation by 3 so that I end up with a 6x right here. And so then I have to multiply everything on the top by 3. So then on the bottom, what I'm going to do is multiply everything by 2. So then I have actually, you know what? Let's do a negative 2 here. So then I've got negative 6x. So then I'm going to have opposites in my x's. So let's go ahead and distribute the 3 all the way through the equation on the top. So in doing so, we would have 6x minus 9y is the same as negative 36. And when we distribute that negative 2 all the way through, we would be left with a negative 6x plus 4y. And that would be the same as negative 4. And so in combining and these two equations, and we're adding, that's going to eliminate. So let's go ahead and add. We see right here this is eliminating. That's 0. We're left with negative 9y plus 4y, so negative 5y. And that would give us a negative 40, because we're adding a negative 4 there. Divide both sides by that negative 5. Then your y you're left with is 8. So we have a positive 8 there. pick one of the equations to put 8 in for y. I'm going to pick, let's see, the top one here. So 2x minus 3y, which I'm saying is 8. And that's going to equal negative 12. So 2x minus 24 is negative 12. So when I add 24 to both sides here, I'm left with 2x. And 2x would give us the same as 12. And then divide both sides by 2. So we're left with x being 6. So our ordered pair would be 6, 8. You could check your work too on all of these. You could take that ordered pair, for example, here 6, 8 is our answer. Plug it into both of the equations at the top. In 6 in for the x and 8 in for the y, and make sure it's true for both of them. If you graphed them, that's where they would intersect if you wanted to really spend some time graphing, practicing your graphing. How many solutions here does this system have? So looking at this, we're going to have to change something up to have opposites that are going to eliminate. So let's multiply the bottom one here. Let's make this a negative 12 x. So we're going to multiply by negative 4 all the way through to every term in the bottom. So we'd have 12x minus 8y is 20. That'd be the same because we're not doing anything there, but we're going to multiply that negative 4 through. Let's see, so we've got 8y, and that's going to be the same as negative 20. And now what happens here is not only are those x terms going to eliminate, but so are the y terms. When we add here and we look, this eliminates, and this is also going to eliminate. So we're left with 0. And notice over here, this is also eliminating to 0, and 0 does equal 0. Whenever this happens where you have some number equaling the same number, when we use this elimination method, this means there's infinitely many solutions. This is like when we were graphing and we graphed a function, and then we noticed as we were graphing the second function it was the same line. They are the same line. They have everything in common. So our answer is infinitely many solutions. Can you say I can solve systems using elimination? Write a summary and reflection and be prepared for the work time in class.